Boys and girls, this is Mr. Morendi. Today I'm going to talk about earthquake. I think tomorrow we are writing our geography paper 1, which is going to be made up of your climate and weather, geology, and map. So my lesson is going to focus more on map interpretation, but I just want to outline some of the sections that make point for paper 1. We've got map skills and calculation, which is got a total of 10 marks. Then we have got map interpretation, which is a total of about 12 marks. Then we've got GIS, which is a total of about 8 marks. So if you combine all the marks for these 3 sections, you get a total of 30 marks. And boys and girls, I want to tell you something. This is very easy. It's very easy for you to get more than 20. Okay, more than 20 out of 30, or even total as we have 10 out of 30. But maybe what it only means is that you need to practice more. You need to make sure that you go through your break, you do those calculations, you try to apply the content from different topics that you have covered so that you are able to get the answers, especially when it comes to map interpretation. So I'm going to start with topographical map. Then after topographical map, we'll also talk about the orthophoto map. I'm just going to look at the basic features of these 2 types of maps. Okay. So the first thing that I'm going to talk about, as you can see, we have got 2 maps here. We have got maps of map of Ladysmith. It's more or less the same map, okay? Map of Ladysmith, that's what you are going to use. So on this map, I'm going to identify some of the features that you find on a topographical map. So as you can see, this is your topographical map. I'm assuming that most of you know what a topographical map looks like, and this is your orthophoto map. I'm going to start by talking about the topographical map. That's the first thing that I'm going to do. So when it comes to topographical map, boys and girls, the first thing that you have to do in order to identify whether it's topographical or orthophoto, you start by looking at your scale. You can see from this map, we have got a scale here. That is 1:50,000. That is our scale, and when it comes to scale, basically we have got 3 types of scale. Remember, we have got our ratio scale, we have got our line scale, then we have got our weight scale. So this is an example of your weight scale. Obviously, when it comes to scale, we're looking at the relationship between the distance on the map and the distance on the actual ground. That's what the scale is all about. So when it comes to a topographical map, we have got a scale of 1:50,000. We have got a scale of 1:50,000. Same applies when it comes to your orthophoto map. You also have a map on top here, which is 1:10,000. So the first thing that can help you to identify the 2 types of maps is in terms of their scale. You look at the scale here, you can see it's 1:50,000, there is 1:10,000. So this type or kind of scale, we call it a ratio scale, because obviously it shows in numbers, it showed in numbers on numerals, as you can see there. So basically we have 3 types of scale. We have got this that we call a weight scale, a ratio scale. Then we have got a line scale. As you can see here, there is the line scale. You can also see we have got a line scale here. Then the last type of scale that we have is a weight scale. You can be asked, okay, it's one of the questions from the map that change the weight scale, okay, the ratio scale into weight scale. So if I'm to change this ratio scale into weight scale, it becomes 1 centimeter on the map represents 50,000 centimeters on the actual ground. That's how you can actually change or convert it from a weight scale into from a ratio scale into a weight scale. So how do you differentiate the 2 maps? The first thing that you are going to look at is your scale. That is number 1, the scale. Which means when you're looking at the scale of a topographical map, you can see it's 1:50,000 centimeters. When you look at the scale of an orthophoto map, you can see it's 1:10,000 centimeters. So the difference between the 2 types of scale maps is in terms of their scale. This one you can see is 1:50,000, this one is 1:10,000 centimeters. The next thing that can also help you to actually identify or differentiate these 2 types of maps is your contour interval. Remember, your contours, they show the height above sea level on a map, or features of general topography of an area. That's what the contours does. So when it comes to contours, now we are now saying we want to look at the difference in height between 2 contours. This is what gives us a contour interval. Like for example, let's say this is contour line, this is contour line, this one is 1020, this one is 1000. If we are to look or to consider the difference in height between the 2 contours, here we have got 20 meters. We have 20 meters, which, like I've already defined, is what we define as the contour interval. So your topographical map, when you look at it, it has got a contour interval of 20 meters. That's how you identify a topographical map, which means you can be asked as a question on one of the questions on your under your map work section, what is the contour interval of a topographical map? You should know that the contour interval of a topographical map is what? Is 20 meters. When it comes also to your orthophoto map, how do you know the contour interval of your orthophoto map? You also look. You can see at the bottom here below the line scale, there is the contour interval of 5 meters. So we have identified two things that differentiates a topographical and orthophoto map. Number one is your scale, which is your topographical is 1:50,000 and your orthophoto is 1 is to what? 1 is to 10,000. That's one thing. Then secondly, your contour interval, which means here under topographical map, the contour interval is 20 meters, and on your orthophoto is 5 meters. So these are the two things that we have used to actually differentiate a topographical from an orthophoto map. The third thing that we can also look at is we look at whether this is a small scale or a large scale map. How do we come to that conclusion now? I want to show you the basic statement that will help you to understand that. The larger the number, the smaller the scale. The smaller the number, the larger the scale. So we want to come now and look at the scale of these two different types of maps. Which one has got a larger number? If you have to look at these two types of scale, which one has got a larger number? You have got your topographical map, you have got your orthophoto map. So we are saying now for our orthophoto here is 1 is to 10,000. Okay? We are saying for our orthophoto is 1 is to what? Is to 50,000. So when you look at these numbers, which number is large? You can see that the larger the number, the smaller the scale. So this is the large number, okay? Which means our topographical is a small scale map. That's what it means. Our topographical is a small scale map. The smaller the number, the larger the scale. So this means that our orthophoto is a large scale map. So we have identified three things. Number one, scale. We have said that the scale of a topographical map is 1 is to 50,000. The scale of an orthophoto is 1 is to 10,000. That's number one difference. Number two, we have identified the difference in terms of the contour interval. I've explained the difference in height between two contours. The topographical map is the contour interval of 20 meters, and the orthophoto is the contour interval of what? Of 5 meters. So the three differences between the topographical and the orthophoto map are: one, scale; two, contour interval; then number three, you identify them in terms of whether it's a large or a small scale map, of which we have concluded that the larger the number, the smaller the scale. The larger the number, the smaller the scale. Which means our topographical map has got a large number, that makes it a what? A small scale map. Our orthophoto has got a smaller number as compared to the topographical, which means the smaller the number, the larger the scale. So these are the three differences between your orthophoto and the topographical map. Okay. Let me move on to the next one. Okay. So now that you know the differences between your topographical and your orthophoto map, remember, when it comes to these two types of maps, there is information that is presented on these two types of maps. So we need to be able to interpret or to make sense of the information that is on our map. So what I'm going to talk about today is mostly map interpretation. How do you interpret the map? How do you use the information that is on the map in order to give the correct answer? Remember, our target is to make sure that if we are not going to do well in our map work, let's talk about 20 out of 30, but I expect you to totalize, that is to have your 30 out of 30. So the first thing that we are going to look at is, when you're looking at this map, obviously on these maps, especially the topographical map, let me start with it, you'll find that there are features that are on the map, on this topographical map. So these features that we have on this map are divided into two. We have got natural constructed features. Okay. Natural and constructed features. Okay, what do we mean by that? We are now saying that we have got features that are natural and features that are constructed or man-made. Like for example, let me talk about a river. River is a natural feature. Okay, so it means when you talk about natural features, let me just write a river here. We can also talk about mountains, of course. Mountains, you find them on a map. These are examples. I'm just going to just look at just a few examples of these. When you talk about constructed or man-made features, if you look at this map, okay, I want you to make reference to your key. This is your key or a reference. It contains the symbol and the meaning. So it means you have the symbol, then you have also the meaning. There's no way you can be able to interpret the map without using the reference or without using the key. So before you start analyzing the map, you need to understand what these symbols mean. You need to understand your key. This is the only way that you can be able to understand the map. So you need to start or to make reference to your key. But on this map, they call it a reference as well. So the first thing that you need to do is, once you are aware of the meaning of the symbols, then you can be able to identify whether it's a natural or a constructed feature. Like for example, you can see here it's natural. I've talked about a river. I've talked about a mountain or mountains in general. When I'm talking about constructed, if you look on your map, the one that we are showing now, if you look on your map, you can see that we have got roads. Roads, of course, they are constructed, they are man-made features, we construct roads. You can see we have got secondary roads, we have got bridges, and these things are constructed or are man-made features. So I can talk about a bridge here. I can talk about a road here. Okay? I can talk about the buildings. Okay. So I look at two types of features. That is your natural and your constructed. But however, these features is natural and constructed. They are further categorized into three. Okay, we have got what we call line symbols. We have got what we call point symbols. We have got what we call polygons. Okay, or area symbols. Okay. What do we mean by that? When we talk about this type of features that we have on the map, of course we talk about the natural and constructed, but they are further categorized into line, point symbols, and polygons. That's how they are categorized. They are categorized into your line, your point symbols, and your polygons. And these three are known as vector data. Vector data, and you find this on your topographical map. This vector data, types of vector data, you've got your line symbols, you've got your point symbols, and you've got your polygons. I'm going to show you examples of this, which means now we are now saying, regardless of them being natural or constructed, some can be categorized as line symbols, they can be categorized as point symbols, they can also be categorized as area symbols. I'm going to give you an example of line symbols. I'm looking at the shape that they assume, like a river. You can see there is a river here, there is a river here that is in blue. That is an example of a natural line symbol that you find on a topographical map. The river that is in blue, you can see this is an example of a natural line symbol that you find on a topographical map. I can also talk about a road. You can see this is a road that is on our map N11. This is an example of a line symbol. It's a constructed line symbol that you find on a map. So we have said we have got natural and constructed, but now these are categorized as vector data on a topographical map. So under vector data, we have got the line symbols, of which I've talked about the river, which is natural. I've also talked about a road. Of course, there's a lot of examples. You can see also the trekking line. You can see here the trekking line that we have here also is part of the line symbol. You can also look here where we have got our dam. The dam wall is also a line symbol, but the dam itself, we are going to talk about it as an area symbol, but a line, dam wall is a line symbol. So I've just given you examples of features that are both natural and constructed, but are categorized as what? Line symbols. Then we have got what we call point symbols. If you come to your map, okay, let me come closer. You can see place of worship, okay. You can see post office, OP. There's a point, PS. So these are constructed point symbols. I can also show you here. You can see here there is a number, a dot, then 1159. We call it a spot height. It's an example also of a point symbol that you find on a topographical map. You can also go to your trig beacon. You can see 313. 1073.3. So on a trig beacon, there's a triangle. You've got your 313 here. You have it as your beacon number. Then you've got here is a height. So this is an example also of your what we call a point symbol that we find on a topographical map. Then we also have what we call polygon or area symbol. Like for example, we talk about, you can see here. Let's go to our key. This is a cultivated area. You can also see this is more like a residential area or built-up area where people live or stay. This is an example of what we call an area symbol. You can also take your dam as an area symbol as well. These are the three types of vector data that we have on a topographical map. We have said, number one, we have what natural and constructed features. So, natural and constructed features, they can fall under line symbol, point symbol, or even polygon. It depends with the shape that they assume. Like for example, the river, we've said that line symbol, we've talked about road being a line symbol, point symbol, we've talked about the trig beacon, we've talked about the spot height, we've talked about how the post office, how some of the buildings are represented on a map. These are examples of point symbols. Then when it comes to your area symbols or your polygon, we've talked about the built-up areas, we've talked about the cultivated areas also. These are examples of what we regard as the area symbol of the polygon. So this is very important, especially when you are interpreting maps. You should know that we have got natural and constructed features, and these natural and constructed features, they are further divided into line, point, and polygons, and they are also known as what? Vector data. Vector data also, if we are to talk about here as in general, is also known as spatial data. Okay, that's part of vector data. So you've got line, point, and polygons. That's what we have on a topographical map. On the same topographical map as well, you can also be asked to find the direction in which the river is flowing. Find the direction in which the river is flowing. How do you find the direction in which the river is flowing? So you come to your map now. Look at the angle at which the tributary is joining the main river. It's joining at an acute angle. You can see here, this is the river joining at an acute angle. So this shows you the direction in which it's flowing. You can see here in A1, we have got this river. The tributaries are joining at an acute angle. The direction in which the acute angle is joining the main river will tell you the direction in which the river is flowing. Number two, you can also make use of your dam wall. This is your dam, as you can see in A1. The river, it flows towards the dam wall, not away from the dam wall. So if you see that where the location of your dam wall is, the river will flow towards the dam wall. If you can check here, it can tell you that it's flowing towards the southwest. Why? Because of this dam wall that is here. It's flowing towards the what? The dam wall. You can also check when you're looking on your, we have to have used number one, the dam wall, number two, the angle at which the small tributaries are joining the main river. Then number four, what we can also use is we look at the height, okay, the contour height on our map. Obviously, the river flows from highland towards the lower land. Obviously, we have got the source of our river, where the river starts. Obviously, it's an upland. Of course, I will just try to demonstrate this, okay? Remember, when you're looking at the profile of the river, you've got your river source here, then you've got your river mouth here. Usually, a river source is from an upland and it flows down, okay, it flows downwards, okay. So obviously, when you are looking at your map now, you want to find the direction in which the river is flowing. You have to look at the height of your contours. You can make use of your spot heights. You can make use of your trig beacons. They tell you the topography of an area. Where we have a highland, where do we have the lower land? So they can also help you to identify the direction in which the river is flowing. The other thing that you can also do when you are interpreting the map work is they can ask you about the drainage density, which is the number of streams, the total length of streams per unit area. Which means when you're talking about now, about what we call the drainage density, okay. When we talk about the drainage density, okay. I want you to substitute your your drainage. Just substitute maybe with stream. We are talking about the number, total length of streams per unit area. So we are now saying now when you're looking at our map, like this, when you're looking at our maps, okay, we want to look at where do we have more streams, where do we have less streams. That's basically what you're talking about, the number, total length of streams per unit area. So when you're analyzing now, interpreting your map in relation to the drainage density, you want to find out those areas that has got more streams flowing. Like for example, you can see here there's a lot of streams flowing, which means there's a higher density. Okay, there are more streams. You can see here we have got a few streams flowing as compared to these. You can see here we have got also more streams that are flowing. So you need to know what are some of the reasons behind higher drainage density and lower drainage density. Okay, so what we are supposed to do is you look at it this way. You are looking at two concepts. That is your surface runoff and your infiltration. You compare the two concepts, that is your surface runoff, and your infiltration. Where we have got more surface runoff, we are likely to have higher drainage density. Where we have got more infiltration taking place, we are likely to have low drainage density. I'll just give an example. Let's say we are looking at two types of slope, the steep slope and the gentle slope. Think of a steep slope. Obviously, on a steep slope, water will not be allowed to settle for a long period of time, which means as soon as it rains, the water starts flowing, which means we are bound to have more surface runoff on a steeper slope. And on a gentle slope, water is allowed to settle, which means it can infiltrate, and we are likely to have less streams flowing. So we compare the two process of surface runoff and also infiltration. So when it comes to your map now, how do you interpret your drainage density? You're going to look at the steepness of your slope. Obviously, if you look here where we have got more streams or where we have got a higher drainage density, you can see that it's steeper as compared to the areas where you have got lower drainage density. Why? Because you can see with the contours that are further apart. So drainage density is a concept that you can be asked to analyze on a map. You need to know the reason behind higher drainage density and lower drainage density. I've talked about the steepness of the slope. You can also talk about the amount of rainfall that is received. When we are going to receive a lot of rainfall, obviously we are likely to have a higher drainage density as compared to when we just receive, there's maybe more like a drizzle, rainfall of low intensity that can rain for a long period of time. We are likely to have what? Lower drainage density. You can also talk about the aspect. If you look on your map, just check where we have got more vegetation. Obviously, where we have got more vegetation, there's bound to be more infiltration because the water is intercepted before it gets to the ground. Hence, it's going to be more infiltration. We have got lower drainage density. But where there is deforestation that has taken place, the trees has been cut, which means the soil is now compacted, there's reduced infiltration. There's bound to be more surface runoff, then we are going to have higher drainage density. So the most important thing when it comes down to your map interpretation, we are saying now, you look at the number of where you have got more streams, which means there's a higher drainage density. Where you have got less streams, which means there's a lower drainage density. The other thing that can also be assessed on is when you're looking on your map, the concept like your aspect, how did aspect determine where people can live or where people can stay. Remember, we say that in the southern hemisphere, north-facing slope receive more sunlight as compared to the south-facing slope, which means north-facing slopes are warmer as compared to the south-facing slope. I'm talking in relation to aspect, which is the angle at which the sun, actually the insolation, okay, strike there. Like that's basically what you're talking about. So saying in the southern hemisphere, north-facing slope are warmer as compared to the south-facing slope. So you should be able also to interpret using the map. You should also be able to, okay, when you're looking at it, okay, how is the landform like? Where is the north-facing slope? Where is the south-facing slope? So this will help you to interpret in the concept of aspect. And also you can see from what we have got industries on the map, which means the concept of urban heat highland. I think it can also come into play. The pollution doom, how are the temperatures, those areas close to the urban area, higher than the surrounding areas. So you should be able to analyze from the map. If you go to your map, you can see where is the location of industries, what do you think the pollution that is coming from the industry is contributing to high temperatures in the urban areas. So you should be able to do that, but using the information that is on the map. And then the other aspect that you can also look at is when it comes now to the type of rivers that we have. Remember, we also looked at the different types of rivers where we talked about perennial and non-perennial rivers. So when you talk about a non-perennial river, remember a non-perennial river, it has got a dotted blue line, and a perennial river has got a solid blue line. Okay, so we are talking about perennial, which means it flows throughout the whole year. When you talk about a non-perennial, which means it's seasonal, it's periodic, it doesn't flow throughout the whole year. I'll show you just examples. Of course, this one is more like a permanent river. You can see it flows throughout the whole year. That's what makes it what permanent or is perennial. But when you look at other rivers here, okay, you can see their dotted lines. It means they are periodic rivers. So if you look on a map and you see we have got more of non-perennial rivers, you'll see that maybe this area doesn't receive a lot of rainfall, which means that it can also be supported by the number of dams that you have, the number of water tanks that are there, the number of dams that are there. You can also have a lot of non-perennial. It tells you that maybe the area does not receive a lot of rainfall. Okay, reservoirs, these are some of the things that you can identify on a map in order for you to come to a conclusion to say this area does not receive a lot of rainfall. So you make use of the information that is on the map. We are now analyzing with the information that is on the map. The other thing that you can also be asked when you are interpreting the map is, if you check here, it says an extract from 2829 dB. So what you need to do is you need to know what this 28 represents, what this 29 represents, what this D represents, and also what this B represents. So this is what we call map coding, the map referencing. So we have got the first two letters. It gives you the latitude. This gives you the longitude. The D is the bigger block. E is the smaller block. Okay, smaller block. I'm going to explain what I mean by that. When you come to your map here, it means when you're looking at your map, remember each and every place that you have on Earth, it exists in two hemispheres. It's either north or south of the equator, or west or east of the Greenwich meridian. So when you look at your map, South Africa is in two hemispheres. It's south of the equator. You can see here there's 28 degrees, 31 minutes south. Then it's also on the eastern hemisphere. You can see here we have got 29 degrees, 45 minutes east. So South Africa, all the maps that you have in South Africa, you have two hemispheres. That is your south, which is south of the equator, and your east, which is east of the Greenwich meridian. So you've got south of the equator and east of the Greenwich meridian. So when you are looking on your map now, you find that it has got two hemispheres that are shown. There is 28 degrees, 31 minutes south. 31 minutes south. You can see here. Then you have got your 29 degrees, 45 minutes east, which means your map is shown in degrees and minutes. You have got 28, 31 minutes south, and 29, 45 minutes east. It's shown in degrees and minutes. You should be able to identify your latitude, which means your latitude starts from here, 28, 31. You can see we are going to count going downwards, which means your degree remains 28 degrees. The only thing that is going to change is the minutes, which means at the end of this grid or block, 31, 32, 33, 34, 35, 36. That's why here at the bottom we have got 28 degrees, 36 minutes, because the only thing that is changing on this map is the minutes, but the degree is still the same. So we have got 28 degrees, 31 minutes south, then you have got 28 degrees, 36 minutes south. You should be able to know the latitude that they increase going southwards, because the number is increasing going southward. What is increasing is the minutes, but the degree is still the same. When it comes to your longitude, you can see from here 29, they are increasing also going towards the east from the Greenwich meridian, which means you have got 29 degrees, 45 minutes, 46, 47, 48, 49. That's why you have got 50 here. So the number are increasing going towards the east, because South Africa is in the southern and eastern hemisphere. So you should know how to interpret where your latitude going downwards towards the south and your longitude going towards the east. So on this, you have got your 28 as your latitude, then you have got your 29 as your longitude, then you have got your D as your bigger block and your B as a smaller block. How did we come to that? Okay, I'm going to demonstrate how we come to that. So whenever maps are done, okay, what they do is they divide the block or the grid. They divide the block into 4 blocks. Okay? I'm going to do it like this. I'm going to take this as my 28. I'm going to take this as my 29, which is your latitude. It's protruding here, then your longitude. So they divide the block into 4 blocks. That is your A, B, C, D. Remember, whenever we talk about coordinates, whenever we talk about the location of a place, we want to find the exact location. So we are saying now our block or our grid is divided in 4 blocks. That is A, B, C, D. That's what we do. Then we further divide each block into 4 again, which means we are going to further divide each block into 4. We have A, B, C, and D. 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 So this is what we have now. We want to find out where exactly this map was taken from, because it's an extract from 28, 29. So we are saying now this is 28 latitude. I'll just say latitude 28. Okay, latitude 28. This is longitude. Longitude 29 degrees. Okay, it's going towards the east, it's going towards the south. So we are saying now our map was extracted from 28, 29. This is 28 latitude, 29 longitude. Then the bigger block D, A, B, C, D. This is the bigger block D. This is the bigger block D, A, B, C, D. Then the smaller block B, which means our map. This is an area that is shown on our map, which is 28, 29 DB. This is the area that is shown on our map. That's how they come up with this map reference or map code, the 28, 29 DB. 28 latitude, 29 longitude, bigger block A, B, C, D. In this bigger block, this is our D. The smaller block is B. So which means what we have here, which is 28, 29 dB, is only this area. It's an extract from 28 dB landscape, Ledsmith map. So this is what is shown on your map from the whole block A, B, C, D. So 28 latitude, 29 longitude, D bigger block, B smaller block. So you should be able to interpret this map code or map reference that you've got the latitude, you've got the longitude, the bigger block, and the smaller block. You should be able to do that. Okay. You can also be asked to write the 6 grid reference. Okay, let me not say 6. Okay, you can also be asked to write the coordinates of a feature on the map. Remember, we have got here at the top, we have got 28 degrees 31 minutes south. Then we also have 29 degrees 45 minutes east. Okay, so we are saying now, in order for you to write your coordinates in degrees, minutes, and seconds, you should take note that already your map is shown in degrees and minutes. The only thing that you need to calculate is your seconds. How do you come to that? Your 1 degree is equivalent to 60 minutes. And your 1 minute is equivalent to 60 seconds. So whenever you are asked to calculate, let's say, the coordinates of, let's say, H on this map. Let's say H on this map, okay? Already you have got your degrees and minutes. I'm going to write the degrees and minutes. You can see there is my H is in B1. So I'm going to find the degrees and minutes first before I calculate the second. So what I'm going to do, I'm going to find, okay, there is 28 degrees already. You can see here at the top, then 31 minutes. So, but my H is in the next block, which means 31, here is 32, then you go to 32. So the H is behind 33, which means I'm going to take 32, then 33. So it's going to give me 32 minutes. Obviously, I have to write my seconds. How do I write my seconds? Remember, what I'm going to do now is I'm going to take my ruler. I'm going to take my ruler. I'm just going to assume, okay? I'm just going to make an assumption. So I'm going to take my ruler, which means I'm going to measure my distance from 32 minutes going towards H. I can say the distance from here, let me say the distance from this where 32 starts up to where H is. You can see I've highlighted with the green marker. I'm going to use my ruler. Let's assume that I have got 14 millimeters, okay? Then after that, what I'm going to do, I'm going to measure the whole block from where to start up to where it ends. Let's say I've got something like 37 millimeters. These are figures that are verified. Then I'll multiply by 60 seconds. Okay, so I'll have 14 millimeters over 37 millimeters multiplied by 60. Okay, whatever I'm going to get, I'm not going to give you the answer. I want you to do it yourself. Whatever answer you're going to get, 14 millimeters over 37 millimeters. Then let me take my calculator so that I can calculate. Okay, so I have 14 divided by 37 multiplied by 60. What will I have? I have 22.7. I'm going to convert it. I'm going to make it 23 seconds. You see, I'm going to make it 23 seconds, okay? I've used this. I have measured from here up to there. I want to find the latitude from here up to there, 14 millimeters. Then the whole block is 37 millimeters, okay? I'm going to do that also to my to measure my longitude, which means I'm going to check the location of H in relation to the longitude. So I can see I've got 29 degrees. Remember, I've put the hemisphere here. Then I'm going to check my minutes. This is 45. Then it goes to was 46, which means it's still on 45. I'll have my 45 minutes. Okay, I need to know now the seconds. So I'm going to do the same thing. Where is my H? My H is there. I've said, okay. So I'm going to measure it from here up until where my H is. If I'm going to measure, it's more or less I would say half, okay? So slightly above half, okay? I'm gonna take it like, let's say 27. I'm gonna take it like 27 millimeters. Remember, I'm just use this as estimation. And I know from there up to there it's around 33 millimeters. Then I'll also multiply by 60 seconds. So what I'm going to do now, I'm gonna say 27 over 33 multiplied by 60 seconds. What is my answer? I've got, as you can see, I've got 49, which means I'm going to get my 49 seconds east, which means if I'm to write the coordinates of H in terms of degrees, minutes, and seconds, I'll have 38 degrees, 32 minutes, 23 seconds south. Okay, this is my degree, this is my minutes, this is my seconds, this is my hemisphere. My degree, my minutes, my seconds, my hemisphere. This is the symbol for minute, degree, for seconds. So that's how you do it if you want to write the coordinates of a place, including the degrees, the minutes, and the seconds. Okay. Then the other thing also that we can talk about, okay, let's move on to our orthophoto. I'm almost finishing now. I know it's sorry for making it long. So when it comes to our orthophoto now, the first thing that I want you to understand is orthophoto is very easy. Okay. So I want you to go to your topographical map area of the orthophoto. It means what is here is what we are being shown on a topographical map. That's why they say area of the orthophoto. So if you fail to understand some of the features that are found here, just come to this box, come to this box, come to this box, come to this box, because this box is the area of the orthophoto, which means what we have here is what is indicated on our topographical map. You can see that some of the features here are clear. You can see them. You can see there is a river here. Of course, it's a meander. You can see there is a river there. You can see this is a built-up area. You can see you've got some tributaries where there's a higher drainage density here. You can see also, what else do we have? Maiden Castle. So when it comes to this now, you might have challenges in interpreting this, but check here, there is a Maiden Castle. Come and check here, there is a Maiden Castle. Come and check here. There is this meander, as you can see. If you check here, there's also this meander, which is part of this river. So everything that is on the orthophoto map is shown on the area of the orthophoto on the topographical map. So this should make your life easier because it helps you to identify the features that are on the orthophoto map. So in short, orthophoto map is a combination of your aerial photograph and your topographical map. What do we mean by that? Basically, we have got three types of aerial photographs. We have got vertical aerial photograph, we have got oblique, then we have got horizontal photograph. Okay, let me just try to demonstrate in a few seconds. Okay, so your aerial photograph, we are saying now you are taking a photo above the earth's surface from an airplane or from a satellite. You are taking from 90 degrees vertical. Okay, you are here and you are taking this part. This is your vertical aerial photograph. When it comes now to your oblique, oblique simply means at an angle, which means we have got high oblique and lower oblique, which means high oblique is at 60 degrees and lower oblique is at what? 30 degrees. That is your oblique aerial photograph. Then we talk about horizontal, which means you are taking from here, from the earth's surface. So you've got types of aerial photograph. You've got your vertical area, you've got your oblique, then you've got your horizontal. So your orthophoto now is a combination of aerial photograph and topographical map. This is an image. This is an image or a photograph. So what has happened is there is a process of GIS that is called data layering, which means they put information on top of each other. Firstly, it's a photograph. But on this photograph, what have they done? They have put on the contours, which shows the topography of an area. They've also put in some of the features, which means through the process of data layering, we are now combining your orthophoto, which is your photograph, and your topographical map. This is what gives us an orthophoto map. How do you interpret an orthophoto map? Interpreting an orthophoto map is very easy. Number one, you look at the features on the map in terms of their shape. What am I trying to say? I'm trying to say that if you look at natural features, they've got an irregular shape, but man-made features, they've got a regular shape. What do I mean by that? Look at your rivers. They've got an irregular shape. But if you look at your buildings, they've got a regular shape. You can see you are able to interpret an orthophoto map using the feature on the aspect of shape. That's number one. Number two, in terms of size, if you look at, you can see here there's residential areas, but if you check here, you can actually see that this is a factory, and you can also see that these are residential area. Why? Because you're looking at the size of the buildings. Buildings for the factories, they are bigger as compared to the buildings of the residential area. Buildings even of hospitals and clinics, they are bigger as compared to the buildings of the residential areas. So you are interpreting your orthophoto map now. You have started by using the shape, now we are using the size. You can also use the tone. And also the texture. Tone, of course, is it light? Okay, is it dark? Obviously, when you look at where you've got the water surfaces, clear water, because of reflection, it's likely to be darker as compared to mud water. So you can be able to do all that using when you are interpreting your map. So you're using your shape, you have used your texture, your tone, you have also used your texture. Those are some of the things that you can use when you're interpreting your orthophoto map. Then the other thing when it comes to your orthophoto map, the data that is shown on an orthophoto map is called the raster. Raster data. What does it mean? It's shown in pixels or in grid cells. Remember, we said that this is an image. So the data that you have on an orthophoto map is called raster data. It's shown in what? Pixels or in grid cells. Okay, in grid cells. That's why we call it raster data. Here, remember, we said it's vector data. There is what? It's raster data. So boys and girls, this is your orthophoto map. If you can see also, you can be asked maybe when you're looking at this number 10 and 11, this is a river. They can ask you, okay, from this river, it's a meander. Draw a cross-section of a meander. So you should be able to identify which one is the inner bank and which one is the outer bank. Remember, on our inner bank, there's more deposition. On our outer bank, there's more erosion that is taking place. So it means when you are looking now from your 10 and 11, if it's your inner bank, it's going to be more like this, then you have got something like this, okay? So it means you're going to have more, this one as your undercut slope. Undercut slope, okay? Okay? This one you're going to have is as a slip-off slope. slip of slope. This is where deposition is taking place. It's shallow. This is where erosion is taking place. Why? Because it's on the outer bank. So you should be able to identify if they are going to ask you, okay, this is a meander, where is your undercut slope, where is your slip of slope. You should be able to interpret even on an orthophoto map. They can also ask you to calculate maybe the area of this feature 6. So what you do is when you're calculating your area, you know the formula is your length times scale times breadth times scale. So you measure. When you measure this, your longest side becomes your length and your shortest side becomes your breadth. So your area is going to be length times scale times breadth times scale. Remember, today I said I'm not doing calculations, I'm only doing map interpretation. So I'm just showing you how you can actually maneuver around in order for you to come up with, to understand, you have a better comprehension of the orthophoto and topographical map. You can see also how is height on the orthophoto map shown. You can make use of contour lines. You can see these are the contour lines, these are your spot highs, these are your spot highs. You can see this helps you also to interpret your topographical and orthophoto map. So in conclusion, boys and girls, I'm just saying that map work is very easy. What you only need to do is to make sure that you understand what a topographical map is and what an orthophoto map is, what features you find on a topographical and what features you find on an orthophoto map. Being able to interpret what is the scale of these two different types of scale of maps. What is the contour interval? Is it a large scale or a small scale map? So that's all about map interpretation. Please remember, if you are able to do your map interpretation, already you will have your 12 marks. I'm talking about 12 out of 30. Already you have got 12 marks, so it's easy. I think I've also have another video on my YouTube channel which talks about map calculations. I think you'll see that one as well. I also have another one that talks about GIS. I think I managed to simplify it, but as for today, it was only about map interpretation. I hope you've managed to understand some of the concepts that we covered. Thank you.